What's up, calculus students? Going to go over the 2024 free response questions and their answers. Overall perspectives after looking through the problems and doing them. There are some parts that I think you might have gotten tripped up on that are worded a little bit weirdly or asking things that are maybe different than what you practice. There was actually no rate in, rate out problem. The first question, the table problem, was actually this is a position problem. We'll go over that. But everything else that we expected, a motion problem happened. We had a function analysis, though it looked a little bit different. We had a differential equation. We had an area volume problem. We had like an implicit derivative question. So all of that stuff we should have been ready for. So I think even though if you didn't get it perfect, I think a lot of you probably got a lot of points on every question. So let's go through it. Starting with question one, which I can see a lot of people getting wrong because they didn't know what we had. And here's what we have. Before we even worry about the answers, I'm going to hide this really quickly. Let's just understand what is going on. We have the temperature of coffee in the cup at time t. This is not a rate of change. Every single question I give you guys, because it's the ones that students struggle the most with, when you're talking about F, its rate of change, and the rates of change of the rates of change, we usually start with a rate of change. This is the rate of change. This is how the temperature is changing. But in this question, C was actually the original graph, the function, the position. So C is in degrees. C prime is in degrees per minute. C double prime is in degrees per minute squared. Hopefully we picked up on that, though I'm sure many of you actually started in the middle because that's where we've been practicing. So C prime is not an A. C prime is a V. It's just a regular derivative. It's in degrees per minute. Values we get using, we've done it so many times, we get -4 degrees per minute. I bet you this is worth 2 points. I bet you 1 or 2 points. You either could have gotten 1 for the value, 1 for the units, or just 1 for both. We'll see when they come out with the tests. The next thing, we have a Riemann sum approximation, a left Riemann sum approximation, where they're saying to calculate it. And then they say interpret the meaning of this other thing. I'm wondering if they're going to be okay with if you go straight to the second thing. But like the Riemann sum we should have gotten should have just been 985. Now you have your calculator, you should have found it. Again, what do I do with Riemann sums? I find the base lengths and then the heights, the base lengths, and then the heights, the base lengths, and then the heights. This is 5 and then the heights. So that was 985. What does this represent? Well, this is like the accumulation of the position, which is used to find the average. We usually don't talk about the units for what comes before a position, if you're talking about that. But when we put a 1/12 in front of it, we are talking about the average C. They did not want 985 divided by 12, whatever that value is. They just wanted the meaning of it, and it's the average temperature of the coffee in the cup over the interval 0 to 12. Again, we had talked about usually with tables, they give you rates of change. I changed it up on you. I think this is probably worth 2, maybe 3 points. Usually they give points for the Riemann sum, points for the approximation, and then points for the interpretation. So 3 points total for that, see where you fall. So we're at either 4 points total or even 5 points total. We go to 1C where we are given a equation for C prime. Now remember, unfortunately, it goes XVA, C prime. Like they didn't change it up on you. They didn't make it complicated. And they asked you for the temperature of the coffee in time t equals 20. Well, whenever we have equations and we have our calculator, we should graph them. And I went ahead and did that. And we are looking for what's going on and what's making sense. So I have this graphed, and we could look at it if we wanted to. But what the most important part of this is understanding what is this giving you, this y1. And you got to think to yourself, well, I want to know the temperature of my coffee at time 20. I know that C prime, whatever the signs may be, I could look at it, but let's say it was only positive. Actually, it's negative. At least that's what I think it is. Let's just go ahead and graph it. So from it's funny, we should be going from like 12 to 20. We should zoom fit it, and we should see that it's negative. I mean, the temperature should be going down. Yeah, so the temperature's going down because the derivative is negative. Now, that's telling you that the temperature in the coffee is going down. Remember, you have to accumulate your derivative to figure out how much you go down, which means we need some sort of starting point. Well, since this is only existing from 12 to 20, we need to start with C of 12. C of 12's value plus the accumulation, this negative value, would give us C of 20's value. C of 12's value, what is it? It's in the table. So this is something that I can see students being weirded out if you never picked up the fact that C prime is the derivative and accumulating it would give us the total. That could have been a problem. Usually you did not have the fact that in a table you were given the position. You were always saying like, oh, C is a rate of change. So you'd accumulate C to get a position. Here it's like C prime is a derivative. They always do this on the AP exam. They mix up like what's given to you, whether it's something that makes sense to us, F prime, F double prime, C prime, or C double prime. And then all of a sudden they're like, oh, which is frustrating when you're teaching it. Here is a rate of change R. And they don't use a derivative. They don't say, oh, this is an R prime. They say, here's a rate of change R. I actually think they might be going away from this, considering if I think about the last couple of years, they've been saying, hey, this is a derivative. So I actually think about this for the future. But we need to do 55 plus this integral from 12 to 20. So I can see in my calculator, the first calculation I did was the rate of change calculation here. Second calculation I did was the Riemann sum, dividing it by 12, got that. Here's the third calculation I did. Accumulated the derivative, and I added 55 to it to get this 40.329 value. Okay, so that was part C, and this is probably worth 3 points. They usually give you 1 point for having an accumulation of C prime, 1 point for using your initial, 1 point for getting your final answer. So I bet you that first problem's worth 1, second problem's worth 3, this problem's worth 3. So we're at 7. So it means the last part's worth 2. Let's see. Yeah, I could see this actually being worth 1 or 2. They give you C double prime. Determine where the temperature of the coffee is changing at a decreasing rate or increasing rate. This is so important, and this comes down to like what I've taught my students is that if a second derivative is positive or negative, the first derivative therefore must be increasing or decreasing. The original function must be concave up or concave down. Okay? We actually don't care about that part. We care about this part. What are we given? We're given the second derivative. What do we need to do? We need to graph the second derivative, see if it's positive or negative from 12 to 20. I adjust my window to 12 to 20. I zoom fit. You can't really see it. But these are all positive values. I guess you can see the x-axis. These are all positive values. If I start at 12, I can see positive 0.169. If I go to 20, I see positive 0.0599. So my answer is that since the second derivative is positive, the rates are increasing. Or the temperature of the coffee is changing at a blank rate. This is probably easiest enough. Since the second derivative is positive, the rates are increasing. Cool. Second question, very standard motion question that all of my students should have gotten at least 6 out of 9 on. Part A, we have a question talking about when are you at rest in between 0 and 2, and between 0 and that time where we're at rest, are we moving to the right or to the left? We should have immediately graphed our velocity. Understand this is a derivative. So we're back in the world of like given a derivative. We should be graphing 0 as well because we need to find the intersection. We should adjust our window to be 0 to 2. We should zoom fit this. And we see this location. We see our velocity. This is the graph of our derivative. This is the graph of our rates of change. Our velocity is positive until that value. Since our velocity is positive, our position is increasing. Remember, x, v, and a. The signs of v will tell us about x increasing or decreasing. If x is increasing, if my position's increasing, I'm moving to the right. So these are all the things that we think about. We find the intersection, and we say, since velocity is positive, my particle's moving to the right. (1.425) particles moving to the right from 0 to 1.425 because v is positive. That's the extent of which you have to say. You do not have to say if v is positive, that knows that my position's increasing, and if my position's increasing, I'm moving to the right if we're going left and right on the x-axis. All right, part B, find the acceleration. We should have just, in our graph, second calc a dy dx. Now I have a question about this question. The answer I get in my calculator is negative 0.9999995. Now, if you truncate, you get negative 0.999. Now, that's my acceleration. Now, show the setup for your calculations. I believe what they meant for that is you needed to connect that the derivative is the acceleration, the derivative velocity is the acceleration. Now, my question is this my calculator being off when it's approximating a slope? Is the slope actually -1? And I'm going to do that in a second because I'm wondering if negative 0.999 is off of the actual, and I should be saying -1. And this is a question I'm going to have for Mr. Huffaker, who's going to be grading this. But second part of the question is our speed increasing or decreasing? We are in our graph of our velocity. We see our velocity values are negative. You could have written this value down. All I said is the velocity at 1.5 is negative. My velocity is negative. My acceleration is negative. You can see your velocity values are getting further away from 0. Therefore, speed is increasing. The easiest justification is signs of v and a are the same. Now, really quickly, let me just do the hand calculations. We'd have 2t minus 4 over t squared minus 4t plus 5 as the derivative minus 0.2. Let me just plug in 1.5 into that because, boy, this is very intriguing to me. Like, we understand our calculator just uses a slope. It uses a slope, a very, very like tiny slope between 2 points very, very close together. So we have the 0.001s between 2 points. Our calculator is not always accurate. I'm wondering if like the AP test knew that and was challenging you to get the exact answer or to assume. I mean, there it is. Like, this is very interesting. The calculator is alluding to the fact that the exact value is -1, but if I truncate, I'm off. So, this is something I'm going to talk to other teachers, Mr. Huffaker, about to see what's going on there, which is very interesting. Part C, we have a position, we have a velocity, find a future position. Look at that. Like the same thing that we did on the last question, we're doing on this question. It is the most common kind of thing that is done on the calculator portion is that you know a position You know a velocity is going to change. You could either split this into multiple pieces, or you could just accumulate your velocity to figure out your displacement of the position. This plus this will equal that. It's the whole, you have to know that we have a displacement, negative, whatever this 1 to 4 is a displacement. It's a change of position. It'll end up being positive, though there is some positive and some negative stuff going on. If you guys wanted to split this up so that we went from 1 to 1.425, and then from 1.425 to 3, this is stuff that we've done before. A lot of times my students are not comfortable having the calculator do like all the work. So they go like 1 to 1.425, find that value, and then go from 1.425 to 4, find that value. But it's not necessary. So all I did was accumulate 1 to 4, see that positive displacement, add the negative 3 to get my future position. This is always worth 3 points, always, just like on the last question, having your initial position, your accumulation, and that. So if you're counting up your points, where do you stand? Distance is easy, just accumulate your speeds. Good, that's probably worth 1 point, maybe 2. Let's go to number 3, differential equation. Only H's and T's instead of X's and Y's. Yo, you want to do something, you could say H is Y, you could say T is X, and you got a dy dx. You got Y's, you got X's. Could that help you? I don't know, but you're allowed to do that if you wanted to. But let's keep it here. And we started with a slope field, and we just had to sketch something that fits. Easy 1 point. Next, some of the wording starts to get a little bit funky on the no calculator. Okay, so it can be shown that H is greater than 1. We can use that in the future. Find the value of T from 0 to 5 in which H has a critical point. This word critical point showed up a bunch, and maybe I could have asked it more on your quizzes. A critical point is when a derivative equals 0 or is undefined. Okay, yeah, 0 or undefined. I was thinking about my answers if I included the undefineds. It's like when the derivative could change sign. That's a critical point. Determine if it's going to be a max or a min. So what I just did is set the derivative equal to 0. Okay, that's it. Now, H is not what you're trying to find. You're trying to find when what T values. So you got to figure out when cosine T over 2 equals 0. Cosine equals 0 at the verticals, pi over 2, 3 pi over 2, 5 pi over 2. So you didn't have to do much solving to just kind of figure out you got pi or 3 pi. Now 3 pi is 3 times 3, which is going to be closer to 9. Pi is between 0 and 5. So pi is the only value. Now here's the next thing. Since H is bigger than 0, this is when this comes into play. We know that this piece has to be positive, which means if we're looking at H prime signs around certain T values like pi, we know that this is positive and this can change signs. Well, we know that the cosine is positive in the first quadrant before pi over 2. Cosine is negative in the second quadrant after pi over 2. So that's how I know we must have a max. So I say since dH dt changes sign from positive to negative at t equals pi, there must be a relative max at t equals pi. I bet you get a point for identifying pi. I get you a point for relative max with justification. So we're at 3. Which means this question's worth 5 points. And holy cow, if you did not know what to do with this question, I'm disappointed in you. We had this on our quiz. We had this on our test. You should have been prepared for this. Like the question we skipped on our quiz was the area volume. You should have known. Separate your variables. You should have been prepared. There's no tricks here. The antiderivative of h minus 1 to the negative first is log h minus 1. The antiderivative of 1 half cosine t over 2 is sine t over 2. We undid the derivative of t over 2, which is a half. So it's like, yes, this makes sense. We have a plus c. We can take e to the power of both sides. We know what to do with the plus c in the exponent. We bring it down to be an e to the c, which can turn into a c, which helps find a nice, easy c. We don't have to worry about doing anything with logs or anything because the sine of 0 is 0. So we get 4 minus 1 equals c. C is 3, and we get our final equation, which was worth 5 points out of 9. 3e to the sine t over 2 plus 1. How is it distributed? 1 point for separating your variables, 1 point for each antiderivative, 1 point for c and finding c, and 1 point for your final equation. I hope we did well on that. And if the h's and the t's messed you up, you should have changed them to y's and x's. Can somebody get that door? Okay, next. I'm going to pause. I'm going to talk to my students, and I'll come back. Okay, this question was our function analysis question, but it ended up being very much just like an integral question for very different reasons. We started with g equaling to the accumulation of f. They told you that this region R had an area of 12. We actually used that once. We actually used the fact that this is a linear equation more than once. Yeah, he's gone.
Can I grab the FRQs from the next class?
I don't have them. You're going to get them next class. Okay?
Thanks.
We use the fact that that's linear more than just once. So let's just see what happens. So we just need to replace all of the x's with -6. If I go from 0 to -6, we need to know that it's the opposite of -6 to 0. You should have got -12. Easy 1 point. Easy 1 point. 0 to 4, we needed to really pay attention to the fact that this is linear. It is linear. Like it's just it's very hidden there. I didn't like and is linear. We don't actually use this at all. This x equals -2. If you put -2 in for any answer, you didn't need it. 0 to 4, it's just a triangle. It's a triangle. Base of 4, height of 2, it's going to be 4. 0 to 6, it's going to be this triangle minus that triangle. That'd be a negative area, a negative accumulation. We got 3. So not bad, not bad. You're not going all the way to 7. You're stopping at 6. Now they changed it up. They said, okay, this is the one really function analysis. Where do we have a critical point? So this word critical point just showed up a lot more. We always went to like, where do we have maxes and mins? We went to the next step. They said, where do we have critical points? Critical points are when this equals 0. It's when g prime, which equals f equals 0. This occurs at 4. That's it. Not at -2. Psych out. What's your reason for your answer? We have a critical point when g prime, which equals f equals 0. This probably could have been a global point, but I bet you this is worth 1 point. That's worth 1 point. Previous, we had 3 questions, 3 points. Here, now we changed it up. H is equal to the accumulation of f prime. You needed to immediately make the connection that h prime equals f prime, which means h of 6 is the accumulation of f prime. I don't have f prime to accumulate here, but I do have the understanding that the accumulation of f prime is the displacement of f. I should have taken the antiderivative and used f of 6 minus f of -6, and I got -1.5. F of 6 is -1. They put that point there for a reason. F of -6 is a half. They put that point there for a reason. You got -1.5. Now we go to h prime equaling f prime. Now this is the graph of f. F prime of 6 is the slope of f at 6. This is like, they're really going to get you guys if you are people who are memorizers. If you've always like, oh, this is what I do. I bet you a lot of you did h prime of 6 equals f prime of 6 equals -1. But it's like, no, this isn't the graph of f prime, so we don't want the value. We need the slope. They did a good job. I bet a lot of you got tripped up because, you're still working on learning how to be adjustable and adaptable. And it's a tough thing to learn how to do. Now brings us to the last one, which is, I think, like very few people got. H double prime of 6 equals F double prime of 6 equals 0. Why? Because F doesn't have any concavity. 3 points here. There could have been a lot of over 3s on this. Not crazy. If I give this to you twice, you're crushing the second time. But when you see it for the first time, I can see it being a problem. I can see myself next year changing up 8.2 homework so that I do F and I do F prime. And many of you will just try to memorize how to do that, but it's not really the spirit of what we're doing. It's just like be adjustable, be adaptable. So more work for me to do. 5A, it's the implicit curve. They already gave you the derivative, and they actually did not do the part A, which is like show that the derivative is the derivative. You didn't have to use an implicit derivative and have a bunch of dy dx's. Part A was just write an equation of the tangent line. I'm going to go ahead and say this. This is the start of like, wow, why are we getting this and why aren't we simplifying? Like, why aren't they giving us stuff that we can simplify? I plug in 2, 4, and I like double check this in my brain 3 times. I got -4, 3 plus 4 times 4 is 3. I got -4/19 as a slope. Thanks, AP test. I really feel confident about my work right now, which is not true at all. And y minus 4 equals -4/19 x minus 2. And then they said use that to approximate a y coordinate of a point with an x coordinate 3. So you should have like plugged in 3. But then this is another thing of like, yeah, you add 4 to the right side. A lot of you like to simplify. It's like makes you feel good. But like, do you want to take -4/19 and add 4 to it? I hope none of you wasted any time turning 4 into an amount of 19ths because I don't want to do that, and I didn't do that. This is worth probably 2 points. 1 point for the equation of the tangent, 1 point for the approximation. Now comes some interesting questions where they didn't say where is the location of the horizontal tangent. They didn't say where is the location of the vertical tangent. Those things you probably would have done fine. They changed it up. They're making sure you're adjustable and adaptable, which causes probably some problems for some of you. I wish they asked you, where's the horizontal tangent? I don't think you could have found it, but maybe you could have. And I might do that in a second. But here's how I approached it. Is y equals 1 tangent to the curve? Well, if y equals 1 is a horizontal tangent to the curve, is the horizontal line y equals 1 tangent to the curve? Well, if y equals 1 is tangent to the curve, then we're going to have a slope that equals 0 when we have a point where the y coordinate's 1, right? We're going to have a y coordinate of 1 with a slope of 0. Well, if y equals 1, x is plus or minus root 43. If I plugged in plus or minus root 43, I plugged y equals 1 into that. I don't get the derivative that equal to 0. So like when my curve has a point where y equals 1, the x coordinate has to be at these plus or minus root 43s. But the slopes at those points, not 0. So that's one thing I could have done. The other thing I said is like if y equals 1 is a horizontal tangent, if dy dx equals 0, well, that occurs when x equals 0. Okay, well, when x equals 0, I don't have a y coordinate that's 1. So I don't have y equals 1 passing through the point. The other thing that I'm just thinking about you could have done is if y equals 1 is a horizontal tangent, like let's just find our horizontal tangents. Horizontal tangents are when the top equals 0, which when x equals 0, you would have gotten 3y plus 2y squared equals 48. I wonder if this is factorable. Two numbers, 48 times 2, 96. Two numbers that multiply to get 96 and add to get 3. Oh. I mean, is the answer to this equation 1? No, it's not. It's something other than 1. I'm trying to find the actual locations of horizontal tangents. I might use my calculator really quickly, which is 8, 12 and 8. No. That doesn't work, right? 16 and 6. No. Yeah, I don't think it's factorable. I mean, even more reason. So, anyways, it's something where like you probably would have been okay doing it, but the way they asked it, you got tripped up on. Same with this. The curve intersects the point at root 48, 0. I mean, this is easier. They gave you the point. They gave you the x, the y. Is the line tangent of the curve at this point vertical? Give a reason for your answer. You should have said vertical tangent is when dy dx is undefined or when 3 plus 4y equals 0. That's only going to occur when y equals negative 3/4, not when y is 0. So the answer is no. And then part D. You all, my students, should have been prepared for this question because we did this on our quiz and on our tests where we had an implicit curve and we had to take the derivative with respect to t. What is the thing's position, x coordinate position with respect to time? You should have said, what is dx dt? Okay, now there's actually two ways to do this. I'm going to do the way that you learned. And if you take BC calculus, you could figure out like this way, or some of you could have figured out, I bet you there's one specific student who did this a specific different way. Y coordinate is decreasing at a rate of 2 units per second. You need to translate that to dy dt equals negative 2. You have the 0.42. You take the derivative with respect to t, d dt. You should have had a dy dt. You should have used the product rule. Probably a couple points here. One for the product rule, one for the dx dt, the dy dt. The values actually work out nicely. The answer is actually 8. But there's another way to do this. The other way to do this, which I showed you on the key, is dy dx equals dy dt divided by dx dt. Dy dt we was told was negative 2. I don't know what dx dt is, but I can find dy dx at the point 42. Watch, dy dx at the point 42 is negative 8 over 3 plus 8, which is negative 8 elevenths. Is that right? Negative, what was the point? 42? 2, 8, 9, 10, 11, negative 8, negative 8 elevenths. Okay. Does this work? Dy dx is negative 8 elevenths, and that equals negative 2 over dx dt. Did I make a mistake with my calculations over here? 3 times 4 is 12 times negative 2 is negative 24. 4, negative 8. Negative 32, positive 32, 8. Dy dx equals dy dt. Dy dt is negative 2 over dx dt. I mean, that's just true. 4, 2. Oh. Sorry, delete this, or that's not the dy dx for this question. That's great. That's great. They did this on purpose. I just noticed it. They just did this on purpose. Guess what? We're not talking about this anymore. Oh man, this is great. If you wanted to do it that different way, you actually had to come up with the implicit derivative of this new equation, uh, which prevents students from actually doing it in a roundabout way, which is probably something they considered because they're like, that's really like implicit. We really want them to understand derivatives with respect to time, which is really an AB topic. So they gave you a different equation to take the derivative of. Fascinating. All right. So, anyways, that's how you do that. And then we go to 6, a very, very solid area volume problem with one curveball. Find the area of R. We move past R after this. You should have done just like 0 to 2, top minus bottom. I mean, oof. I hope we didn't overcomplicate this, guys. The top equation is x squared plus 2. Hopefully you figured it out. Bottom equation is x squared minus 2x. Okay, so like there's 1 point, maybe 2. Part B, here's the curveball. They said we got these regions put on S that are perpendicular to the x-axis, but we got these rectangles coming out whose base length and height are related. The height is a half the base length. So what we want to do is accumulate all of these rectangles times their skinny widths dx to get volumes. But here's the key. They're asking you, what is the volume of the solid? They actually want you to not only set up an integral, 1/2 base length squared, my base length of that, but they wanted you to evaluate this. They did not want you to leave it like this. They wanted you to find the antiderivative of this. Now, how do you take the antiderivative of 1/2 x squared minus 2x squared? Not using u substitution, but by distributing. We practiced this. You should have been ready for this. It's not something we did on our test, but it is something that we've seen before and we've did a lot of. We get x to the fourth minus 4x cubed plus 4x squared. And now look at this. This is why I was really shocked by this question. I simplified. I took the antiderivative. I left the 1/2 out. I got 1/5 x to the fifth minus x to the fourth plus 4/3 x cubed. Find the displacement of that from 2 to 5. And I get this answer. Now, I dislike the AP exam for this. I mean, it's just become something that you really have to teach. Like, I have to teach my students, don't simplify. Don't simplify, okay? This is an answer. In all mathematics leading up to AP Calculus, it's simplify, simplify, simplify. And then we get to AP Calculus, and I have to teach you guys, stop simplifying. Because I did this on Desmos earlier to check. I found the integral from 2 to 5 of 1/2 x squared minus 2x squared. And I got 82.8. And then I plugged in that big old fraction. I did it on Desmos just because it was quicker for me to do. And I get 82.8. That's not nice. You know, why do they do that? But it's now something like that you as an AP Calculus teacher have to teach. Tell your students don't simplify. Boom. And then we get to part C, the last question of the test. Spin this region S around the line y equals 20. If I spin this region S around the line y equals 20, here is the reflection of my region. Looks something like that. Oh, that was horrible. Looks something like this. And what should we be drawing? Either you're drawing 2 sets of cylinders, one set going to the outside where you're marking off the radius length as a vertical distance 20 minus 0 consistently. And then you're marking off the inside cylinders, blue radius, 20 minus 10. You remember it's pi r squared h minus pi r squared h, or pi r squared minus r squared h. This is the key. The other way to think about it is using one rectangle, which spun creates a washer, and you have the outer radiuses of the washer and you have the inner radius of the washer. You did not have to evaluate this. This is it. The outer radiuses are 20 to 0, consistently, the inner radiuses are 20 minus g of x, 2 to 5 times pi. So that was the test. Overall, curveball for my students was given a position when they're used to be given a velocity. Curveball for my students was nothing on this question. H's and T's instead of Y's and X's. This end is linear, which was sneaky. The fact that we use the words critical points a lot. The fact that they gave this, which I loved. That, which I need to start teaching next year. I can't just accumulate F. I'm going to accumulate F prime from now on. Good job, AP Test. I like this question. Make your students adjustable, adaptable math students, not memorized math students. Thank you for that. The way they asked about horizontal and vertical tangents, not very straightforward. You had to kind of really understand stuff. The fact that you had to take the derivative with respect to t of a new equation and you couldn't use dy dx to use the cheat sheet. If you use the cheat sheet, you got it wrong, which is dy dx equals dy dt over dx dt. And I didn't take the derivative of this and find its dy dx because I just don't want to. The fact that you had to find the volume and take an antiderivative, this helped huge answer. Besides that, I bet you guys did better than you expected. I bet you if you didn't know what you're doing, you earned points and you did fine. Okay. Overall, I think my students were prepared. I don't feel like this was above their heads. I think some curveballs, but I think you guys did fine. So there it is. AP free response answers in 30 something minutes. It's been a pleasure. Later.